So similarly, we have to repeat this experiment and collect this NDCG at K score for various kinds of sample. Okay. So we have one limitations that we cannot collect more data samples. We are having only 500 queries with the ground truth values, and we need to reuse that for each experiment. So in that case, what we have to do, we have to come up with one other concept, that is bootstrapping. And bootstrapping is a very common concept that is used for evaluating this ML model, DL model, even these LLM models. What it happens now, in with replacement, each set, we have to decide that okay, how many times we have to run these systems, system A and system B, on the same data set with replacement. Okay, there might, with replacements means, for example, in Bootstrap 1, 500 queries will be there, but there is a possibility of getting repeated a specific query twice or thrice. Even there is a possibility of not getting opportunity a specific query to get involved in that data set of 500 queries. So that is with replacement. So bootstrapping will come into the picture. For example, we decided that no, we have to do 1000 times bootstrapping. So in that case, what will happen? 1000 times we have to generate different data set, and we have to run these systems, and we have to take NDCG values, and with that all the, for examples, both the systems we have to take the NDCG value for this system A and the system B with all these 170, 160, 170 records, and then we have to calculate the CI. If after the finish of 1000 bootstrapping, then again we have to we calculated CI, and then CIB, and the CIB does not overlap now. Overlap means I have already told what is this. Okay, does not overlap now. So in that case, what happens? No, this becomes okay. There is a significant improvement. There is significant improvement in performance with the system B system. Significant improvement in system B. Okay. Now the question is that among all the variations in stability, we came up that okay, by taking this balanced data set, we fixed the query instability parameters. That was the one component which was getting raised. Now if it happens, even though after that again it happens that we completed 1000 bootstrapping, after that we ran even CIA and the CIB overlaps. Okay, it overlaps. Then what we did? No, there is not any significant improvement in system B, right? So in that case, but this query instability from that 0.05652, it has reduced to query instability. What is that? This point, specific point. Query instability percentage has decreased from 0.652, for example 0.2, it has decreased. But in the meantime, this retrieval instability has been increased. So there is a possibility that, right, it has been increased from, for example, we had 0.2 to 0.45 or something like that. It has been increased. So when we say that CIA and CIB overlaps, but query instability has been reduced, so in that case there is a possibility that okay, these two systems are same only. There is no significant difference between these two systems. Number one conclusion. Number two conclusion is that any other instability may happen there. So what is one is that retrieval instability, another one is that LLM instability. Okay, so those kind of instability. So we need to go one by one to verify that where the actual from where the system is unstable, it is performing better. It's performing better for some queries and does not perform for some other queries. So when it comes to this one, when it comes for LLM instability, then what we can say that in case of LLM retrieval, let's consider first retrieval instability. Then what are the reason of that one? The reason one can be the poor embedding. Then again it is the chunking strategy. Then again it is that high something like that kg traversal depth, then fourth one is the embedding model, something like that. And some LLM instability reason can be, one is that what is that, temperature. Some introduces randomness. First is that temperature, okay. The second is that context window, it may explodes, context window explosion happens. Third is that context window does not get compressed properly. Context window does not get compressed properly, okay. So in these cases what happens, we need to consider one by one. For examples, this retrieval instability, poor embeddings, then we need to check that, okay, what is the embedding techniques used for that one, how that can be improved. There shall be some chunking strategy. There are different kinds of chunking strategy we will be covering in our next sessions, future sessions. So for example, if the chunking strategy is not adequately done, then it will lose the context, it will not it will miss some informations, okay. And the kg traversal depth means whether in order to answer a specific query 3 hops may be required, but it is getting stopped after the first hop. That means it is losing context, it is not retrieving the complete context from the graph, right? And another is the embedding models. Different embedding models would be there for some kind of document. Some specific embedding models would be there, so that it will be able to capture all the informations from the document, right? And so we need to do one by one, we need to check one by one, we need to improve that. Again we need to repeat the complete cycles of this process to see like that whether the retrieval instability has been reduced, and then again CIS and CIB does not overlap. So in that sense you can say like that, okay, system B is significantly better as compared to system A. If same system again it repeats, then again we need to come up with the LLM. So to find out, okay, where is the issue, why this instability comes, then repeat the same steps. CIA, CIB overlaps, does not overlap, then system B is better as compared to. So we need to come up with this kind of strategies, we need to come up with these kinds of various kinds of experiments to come up with a better version of the system, rather than just when it comes, no, instead of improving our architecture, I have seen many suggestions, it comes, no, change the model. GPT 4.1 is not working, you should move to the Cloud Sonnet, we should move to the higher versions. And then that is again by paying so much of money, again with the compute cost, we deploy some new model, but we don't find out where the architectural issue is there. See, this kind of the basic core part is that architecture, how you have to improve the architecture. So the complete system, the complete components, and for what kind of use case, for what kind of scenarios, which components should be improved. What are the different engines, subcomponents needs to be plugged inside that one. So that is the complete architecture. Definitely data pipeline, the good data set, or the additional auxiliary 7 layers architecture, those will be in place. But before jumping to any other model, higher grade model, always try to fix the issue by improving the architecture, right? So that is the fundamental thing that we have learned. So now this is we completed the complete concept. The next session we are going to cover is about the system design and the coding part. Let's start the system design for this one. So what is the objective? All these two concepts that we cover, known as one is the CI, confidence interval, and variation decomposition, those are named as statistical rigor. So what is the objective? It is build a statistically significant uh, or you can say rigorous AI search evaluation system, or the you can say that framework will be better for that one, that can framework or platform that we can say that can evaluate AI search, RAG and KG retrieval systems using what are those? Using retrieval metrics, then confidence intervals, then what is that? Then bootstrap analysis, then significance testing, then variation decomposition, and then experiment comparisons, right? So this is our objective. This is our objective, and now we have to move to the high level architecture. So what is high level architecture? We can say first is that ground truth dataset. So it is having, what is the layer? In that set we can say that different layers. So layers, one is the dataset, and then second is that runners, that means different kind of we have to do some kind of runners activity, right? It is like evaluation runners, like retrieval metrics, ranking metrics, and then some answer metrics. These are some kind of metrics, and those metrics we have to run through. So these are is a kind of some kind of Python class which will be used for some kind of RAG eval, A/B testing eval. So all these will be inside this runner. So when we are saying that RAG eval or A/B testing, so there we are capturing some metrics. So here the third layer is the metrics, and then after capturing the metrics we are performing some statistical testing. So statistics, or you can say the statistical layer, okay? And the next one is about after statistical testing performance, what we are saying that it's a reporting layer, and then after that we are having some results after the experiments, you can say various kind of experimentation layer. After getting the initial report, we are repeating the same cycle. So we are doing some kind of experimentation. So experimentation is that, and the final is that final result. Okay, this is our conclusion that we are doing. So here all these are all the layers are there. Now if we go to this details flow, here I would like to take you to the GitHub repo. So this is our complete GitHub repo. The first one is the dataset layer, and here in the dataset layer we are having ground truth queries. Okay, so I have just kept some boilerplate codes to give that high level architecture and some what are the different files are there required and what will be the different functions are there, so that any senior engineer, AI engineer, can take this as source and then he can extend it to the required codes. So what we are doing at first is that in that ground truth queries.py we are doing the load ground truth dataset and then query. After loading the dataset we are querying by query id and the validate the ground truth dataset schema whether that is correct. So what will be the output from here? It will be like ground truth queries.json query metadata. It will be having informations about the queries metadata and retrieval levels.json. What are the different levels of retrieval? For examples, whether that is from the uh, keyword based search or like embeddings or something, vector embeddings or the KG graph, it is like that. And this is query metadata and the relevance levels are also here. So here it says that validate the levels, query document ID and all this. So after this it will be moving to the metrics where we are calculating various types of answer metrics, ranking metrics, and inside this metrics before that we need to go to runners. Yes, so inside this runners we are having run rag eval. So evaluate the rag queries, run rag evaluation, aggregate rag metrics. So these will be coming for rag under the runners folder. And then run A/B testing, that is evaluate system. A/B testing means two systems, system A and system B we are doing. Evaluate the baseline system, these are there. And after that we are capturing the metrics. So inside this metrics what there will be some kind of retrieval metrics, how the documents are retrieved, how the ranking has been done among these retrieved documents, and how the response is generated, and what is the output of this one. All the metrics like recall at K, precision at K, NDCG, MRR, MAP, faithfulness, answer correctness, all will be the output from this file. After that, after metrics, the statistics will come into the picture, this layer. And the statistics layer, the first one is about bootstrap.py. So inside that bootstrap, generate bootstrap samples. So I have said that in iteration 1000, it will generate bootstrap samples. And the definition of bootstrap definitions. So here, how the output from here again, the bootstrap distribution.json, how those are distributed, confidence interval .py. The next one is about the confidence intervals.py. Okay, so what? Calculate the standard error, calculate the confidence interval, bootstrap confidence interval. Then it is like the, after that it's called significance test. So what is the significance test? It is like when we are in the statistics, we have to perform some kind of paired t-text, because we are comparing two systems, right? And Wilcox test, perform the Wilcox signed rank test, all these kind of test should come here, significance test. And then it will be output like variance report. From here only what will be the variance, it will come. Then the effect size. So effect size means we are saying like that different kinds of how is the difference between system A scores and system B scores will be inside all these files. Inside this file all these functions are there. Calculate the relative improvement, baseline metric and candidate metric, all right. And then after that experiment comparison. So here after collecting this effect size, confidence interval, here we are comparing the two experiments with the compare experiment, rank experiment, identify the best experiment, compare confidence intervals are here. And then after that, then here it will be like the reports will be generated. It's like experiment summary. All the experiment, what the summary, it will be summarized, and then report will be generated, and then final dashboard will be generated displaying all these metrics. Generate metric, visualization, public dashboard, all these. So after that the final results will be displayed, and inside that results all the experiments that we have done, starting from the confidence interval, variance decomposition, what are the variance metrics we have done, bootstrap distributions, various of the experiments, because experiments, when we are doing different kinds of experiment, again one thing is that is related to the model tracking, model experimentation. So how we are experimentation tracking there through some MLOps tools, right? So it is whether we are using any MLOps tools and some whether wet and bias or any other tools we have to capture there. So that is again separate process. When we come to such experiment, then definitely I will cover that in future sessions. If I start covering that, then it will be a huge topic, and it will go out of the context. Then query level results. What are the different kind of significance are there? So different kind of significance report are there. Whether which one is statistically significant. So this is a very high level design document. Any senior AI engineer can take it, and he can proceed with building this AI search evaluation. So here this spreadsheet contains information about all the files, what are the descriptions, input and the output, and the sample functions present. So I will also share this one. You just have a look at this, and then start building the applications. So yes, so this session concludes the complete so this session concludes the system design of AI search evaluation framework. Basically how it happens in an organization that is a matured AI is the matured AI ecosystem. Some organizations, they maintain a separate platform. Platform means it's a kind of service provider and service consumer, right? What is the platform definition? Service provider and the consumer. So it will be like it will act as a base ground level in order to provide some service. So when we say that evaluation framework, so this evaluation frameworks, all the concept like whether CI/CD, various decomposition, bootstrapping, experimentation, A/B testing, all are basic building block of an evaluation system. So instead of rebuilding this complete framework for each and every project, for each and every team, for each and every product, there should be one complete team and the complete infrastructure which will be providing the evaluation framework, and that we say that it's a platform. So AI ecosystem mature companies, they maintain in the platform. Instead of all this in a single GitHub repo structure, they will be having separate GitHub repo structure. Once your retrieval system is already done, then you have to use that GitHub repo structure in order to capture all this, in order to start processing all these systems, right? And it will be a mutual collaboration between the platform team and each individual product development team for the specific use case or the specific product you are building. So then this will be captured and this will be taken care by the platform team. But platform team is a kind of, it's supporting you to provide, to make your work easy. It has already the complete frameworks, its libraries, packages, its plugins, everything is available. They have built. Okay, no need to build it from the scratch. So, but for companies which is limited capacity and just they are in the beginning level of the AI ecosystem, then they can maintain it in the specific project specific, having this kind of repo structure in their main project repo structure as a part of that, or they can make a separate new GitHub repo structure also. So this is all about what we covered today's session, is that how to evaluate. And then there are other aspects of this AI search engine also that I'll be coming to the next future sessions. So in order to get this kind of updates about the system design and where it fails, okay, how it was failing and how we improve that one, where it fails. So please subscribe my channel, click the hit the like button, and do comment what the next session we are going to learn something, or you want to get something more information from me, or you want to give some kind of feedback. Please do this.